Can you hear me?
Yes, I can. Can you hear me?
Yes.
Awesome. How are you doing?
Oh, yeah, good. How about you?
I'm doing pretty good. Thanks for asking.
Awesome. Cool. Well, let's go ahead and get this started then. So basically, I just want to first kind of talk to an overview of a little bit about your background and then just kind of what you're hoping to get out of today so we can kind of target this and get you the kind of the best experience possible.
Sure, absolutely. So, yeah, just briefly my background.
Mm-hmm.
I graduated back in 2011.
Mm-hmm.
My education is in mechanical engineering, and
Mm-hmm.
my career so far has been purely in manufacturing. I've kind of worked my way up to product management.
Mm-hmm.
But the whole time I've been doing like a ton of kind of self-taught programming and coding to the point
Mm-hmm.
where I'm now at a point where I think I have enough skills and know-how to transition my career into software engineering.
Mm-hmm.
And that's what I'm trying to do. So that's
Okay.
kind of the background. Then more specifically,
Yep.
I have about four companies right now that I'm talking to that I'm kind of going to on-site
Yep.
interviews for. The kind of the big one, the one I'm most excited about is Google, which
Mm-hmm.
I have the on-site tomorrow.
Oh,
So
wow.
really, what I hope to get out of this is just as much as possible, try to emulate what that interview is going to be like, just to
Mm-hmm.
kind of see how well prepared I am, or I guess really just to kind of practice and prepare myself for tomorrow.
Gotcha. Yeah, yeah, that makes sense. Cool. And so I can ask your background, like, for these roles you're interviewing for, is there a particular, like, area of focus that you're like, full stack, back end, front end, machine learning, like anything like that?
Yeah, so well, I guess the jobs I'm interviewing for are pretty, I would say, generalist or back end focused.
Okay.
It's not really specialized in any of the machine learning stuff. I know some front
Hmm.
end stuff, but I'm not really interviewing for that. So yeah, I'd
Gotcha.
say more back end or systems level programming.
Okay.
And then
Awesome.
I
Well,
guess
that
I,
sounds
I guess
good.
aside from that, like kind of some of the feedback I've been getting on
Hmm.
some of the interviews I've done is I guess what I kind of want to focus on today for myself
Hmm.
is just kind of making sure I kind of walk through the problem, making sure I kind of walk through the
Hmm.
brute force approach before kind of jumping into a more optimal approach, and
Hmm.
really kind of giving you an opportunity to see my problem solving
Hmm.
strategies versus kind of jumping
Hmm.
straight into some sort of coding or algorithm at the end. So that's
Yeah.
going to kind of be my focus. Maybe try to take a more structured approach rather
Hmm.
than jumping straight into what would be the most optimal way to deal with this.
Yeah. Okay, that sounds good. And honestly, like that's old. A lot of the feedback I have from people who you were interviewing is specifically to do that. So I'm glad that
Hmm.
you've already gotten that feedback and are working on it. So we can definitely do that today for sure. Okay. Awesome. Um, So then, yeah, so basically for the rest of this, obviously we're going to spend, most of the time doing a practice technical interview.
Okay.
Like you said, I'll just try and treat this like I do for a normal interview when I'm interviewing a candidate.
Okay.
Um, so what I'll kind of target is hopefully save, let's say like 10 minutes at the end for, discussion or feedback or anything else we want. So
Okay.
we'll say, about 45 minutes, which is, I think, fairly standard for
Hmm.
the actual technical coding discussion part.
Yeah.
Um, so Okay, cool. Well, I guess let's go ahead and get started then. So, I guess first we need to change this coder pad. What language would you want to code in if you had to pick?
C++. So
C++. plus.
I'm okay. You got it. Cool.
Cool. Yeah, yeah. Okay, awesome. I use C++ plus plus in my job too, so that works. Let me get rid of all the starters. Okay, cool. So the problem I want to talk about today is it's hopefully kind of start simple, but as we discuss it and kind of peel back layers and talk about it more and get to implementing, hopefully there will be some interesting challenges and trade-offs and all of that that we have to kind of discuss and figure out.
Okay.
So yeah, so the problem basically is, for example, you're interviewing at Google, a company like Google that has a huge amount of software engineers, huge amount of computers, obviously is going to be deploying a large amount of apps, services, um, products, right? So
Right.
when you're running a huge amount of services in production like web scale like Google, obviously there's a huge number of these, and more importantly, you need to kind of keep track of them and monitor them and make sure they're all running properly, right?
Okay.
Um, so basically, the problem I want to deal with today is one important part of kind of monitoring these systems is specifically kind of having like some sort of unique identifier for each service, so that like what the difference between two services are, or when one goes wrong, or something like that. Um, so basically, what we want to do is we're going to implement this, what we'll call a service ID generator.
Okay.
Basically, the problem is that we need to when one of our services starts up, they need to get a unique ID that no other service that's currently running is using. Um, this way we can kind of uniquely identify this instance of this service. It's like this app running in this data center that's doing this thing, right? And then that's basically the main part of the problem. The other aspect here is that, as I mentioned, the unique requirement here is that no two currently running services should have the same ID.
Mm-hmm.
But you could have one service get an ID and it stop, and then later another service get that same ID. So what that would look like is we're also going to have this, like, call it return ID functionality, where when a service is done, it'll tell us that ID is stopped running, right?
Okay.
So basically, what this will do is it kind of, lets us know what's currently running, and also lets us kind of uniquely identify everything that's running. So this is the problem. Yeah. Do you have any questions or anything you want to talk about?
Let's see. So, is there any indication of, how many processes could be running, or I guess, how many unique IDs might I need to issue at the same time, right? I'm kind of thinking about, do I need to worry about whether I need to use int or a 64-bit integer? Do I have to worry about the size of the unique ID?
It's a good question. So let's assume that a 32-bit integer is sufficient to hold all possible things that could be running at any one time.
Okay, cool. So 32-bit integer is good. Let's see, what else? So what about concurrency? Do I have to worry about multiple processes coming in at the same time, either requesting an ID or looking to release an existing ID?
Yeah, so for now, let's assume that you can handle the concurrency just by essentially, assume there's no concurrency, at which you can handle any concurrent case by just putting a global lock around everything, and then we can kind of figure out if there's a better way to do that.
Okay. And then I guess maybe the last question for now, at least, is the functionality I'm working on here strictly restricted to generating and managing the IDs themselves, or do I have to hold on to any sort of information about the processes that own those IDs?
Well, so for now, it's strictly just generating and managing IDs.
Just generating and managing
additional information.
All right. So I guess, kind of initial thoughts. This feels very roughly kind of like a memory allocation problem where, you have memory, you have kind of a free memory stack somewhere that kind of increments as memory is released. And it seems a little bit similar to that. But kind of in line with what I was mentioning earlier, I'd like to, kind of go through and outline what a brute force approach would be. And I guess what that might look like is, and maybe I'll just sketch it out here a little bit. Let's see. We'll call this the brute force. So this would be, I'll manage a, let's call it a vector of integers. These will be my unique IDs. And anytime someone asks for a new ID, iterate the whole list to see what the first available ID is, or the first unused integer is. And then the same thing anytime someone deletes an ID, iterate the whole list to find it. So I think something like this should work. The only kind of gotcha here might be that the vector won't store any sort of order. So I might need to get a little bit creative on how I'm adding or removing elements to make sure that the first ID I find is the lowest ID. Or if that, I guess, does that even matter? Maybe that's another question I should ask is, when someone requests a new ID, is there a preference to, use a previously released ID versus generating a new ID, or am I overthinking this and should I just generate a new ID each time?
I think that's a good question. I think there is no preference on order of IDs. The only requirement, like I was talking about, is just that the ID can't be one that's already in use by another service at this time.
Okay, so then really the easiest approach is to simply keep track of an integer, increment it by 1 each time someone requests an ID, and just return that each time, because that'll assure that anytime someone requests an ID, they have a unique ID.
Mhm.
And in this case, whenever they want to return the ID, it would be a no op because I don't need to do anything with that information. I
Mhm.
still have all the information I need to return a unique ID.
Mhm.
The main drawback of that approach is I'll call it memory leak, but it's not really maybe
Mhm.
it's more so memory creep because even if you only have one process at a time that's ever using a unique ID, the memory usage of this ID generator is just going to continue to grow forever and ever, right?
Mhm.
So the space complexity is O of n, where n would be the total number of processes that have ever needed
Mhm.
a unique ID. Versus,
Yeah.
we could do a lot better. The approach that I'm listing out here is actually a bit better than
Mhm.
that. In that now our space complexity is going to be O of, I'll call it M now, where M is simply the number of currently active processes that need unique IDs
Mhm.
versus the total number of processes that ever needed it.
Yeah, and that makes sense.
So yeah, but I still think we can do better than this though, mainly because of this iterating through the whole list to find the first unused integer. I think that's probably going to get pretty expensive as that list tends to grow. And so I'm wondering if there's kind of a way for us to keep track of what's okay. So this is kind of maybe playing more into that parallel to the memory allocation I was talking about.
Mhm.
Rather than iterating through my list of currently used IDs, I'll maintain a second list of IDs that have been freed.
Mhm.
And that could be, I guess, it could be a stack or a queue. So we don't really care about the order.
Mhm.
And I'll just check if that's empty or not. And if it is not empty when a new ID is requested, I'll just pop one off of there and we'll give that to whoever is asking for it. And if it
Mhm.
is empty, I know that every integer from 0 to my last generated ID is currently being used. I'll just
Mhm.
increment that counter by 1 and return that next integer. So
Mhm.
the reason that's going to help us is rather than having this O of n search here, I'll have a constant time pop from the stack or the queue that I have.
Gotcha.
So that's kind of the general approach I'm thinking of. Does that make mostly sense?
Mhm. Yeah, I think that makes sense, and I think kind of the way you approach this all makes sense. It's like thinking
Okay.
about it that way. Yeah.
All right, cool. So unless you have any questions, I think maybe I'll go ahead and start coding that up.
Yeah, that sounds good. Let's do that.
All right, so I mean, there's a few ways to do this. I could do it in an object-oriented approach where everything is contained within the object, or I could do it
Mhm.
more in a functional style, but then we have to pass a bunch of stuff around. So we're going to go ahead and
Mhm.
do this as a class, and we'll call this ID generator. I always forget this colon or semicolon at the end, so we'll put that there. And then the public interface for this is going to be pretty straightforward. We're going to have integer get ID, that will not be const, and
Mhm.
we'll have an integer release ID. And for this, you're going to have to give me an ID to release.
Mhm.
So let's see. Do you need to give me any information here? No. Here, you need to give me information. And I'm not going to tell you anything back, actually. So
Mhm.
that's good. And then here, let's just talk about the data that I'm going to store. So one of them is going to be the last ID that was issued. We'll initialize that at 0. The next will be, so now I'm wondering if I even need to keep track of the IDs that are out.
Mhm.
I don't think I do actually, because I'm only interested in, do I need to give you uh, the next ID here that I haven't issued yet, or one of the ones that has been released back to me. So I actually don't need to store this.
Mhm.
Instead, I'll store here do a stack of integers, free IDs. We'll just initialize that as empty. Okay, so that's kind of the basic structure of our class here. And I'm just going to go ahead and put the definitions right in line here, if that's fine with you.
Yeah, that's totally fine.
All right, so
We
for
don't need a
get,
separate header and CPP file or anything.
yeah, exactly. All right. So let's see, for the get ID, like we talked about earlier, if free IDs dot size is greater than 0. Then I'm going to return free IDs dot pop. Otherwise, I'm going to return last ID. I'm going to do the post increment here because that'll return the value first and then increment it afterwards. Okay, so that looks right. And then for release ID, let's come over here. All right, so how do I do release ID? Okay, this should be, well, do I have to worry about misbehaving clients? In other words, let's say I issued the ID 1, that ID has been released back to me. Do I have to worry about someone trying to release that ID again?
That's a good question. I think for now, no. Let's assume the clients are well behaved. But it is an interesting discussion we can talk about later, which is how you would handle that.
Okay, so this one should be pretty easy. This should be free IDs dot push ID. And man, it kind of seems like at the very least that's the totality of the kind of approach that I was thinking of here. So maybe let's just walk through this once with like a use case just to make sure it works as expected.
Sure. Yeah.
So let's do, let's say 1 get ID. So this would return 0, and then last ID is equal to 1. Get ID. Now this would return the 1. Last ID is equal to 2. I'm gonna get one more ID. This will return 2 equal to 3. Now here I'm gonna release ID to 1. Let's release 1. So now last ID is still equal to 3. My free IDs is equal to 1. I push that onto the stack here. Free IDs at push. Good. And now 5 when I get ID. So now my size here will be greater than 0. So I'll pop that value out. So I'm going to get that 1. Last ID is still going to be equal to 3, and free IDs is now going to be empty. Okay, this looks like it does what we want it to do.
Yeah, I think this is good. Cool. Okay, so yeah, I think this is a good start. So let's talk about kind of how this approach would run. If we actually had this running in a production system. So first, let's talk about runtime and space complexity.
Okay.
Let's kind of formalize that. So what would you say the runtime and space complexity of this solution is?
Sure. So let's see. So the runtime complexity of get ID is constant because since we're using a stack here, the pop is a constant time operation, incrementing integers constant time, and then the same thing with releasing the ID. So pushing onto the stack is also constant time. So the space or the time complexity is constant for either operation. The space complexity here is going to be, why don't I write this down for you?
Sure.
Time complexity is O of 1 for get ID and release ID. Space complexity. So this is going to be O of, we'll call it active IDs, right? So however many services are currently using one of my IDs, no, that's not right. This is going to be O of released IDs. So doesn't matter how many services are currently active, only how many services have, well, shoot, actually not even. This is a little bit more challenging because this is like released IDs minus active IDs. Is that even right? My release IDs start at 0. So, okay, this is more challenging than I expected it to be. So before anything is released, I'm going to kind of walk through this. Before any IDs have been released, my space complexity is just O of 1 because I'm not storing anything. As things get released, then my space complexity, let's just say now all people are doing is releasing, that goes to O of released IDs. but then as more are requested, then that is going to get reduced to released IDs minus um, active IDs. So I guess, I mean, we can maybe talk about an average space complexity here, and really it would kind of depend on, what's going on the client side.
Yeah.
Is it mostly balanced between requests for IDs and releasing IDs? Is there going to be a time where I get a huge influx of released IDs and then kind of a lull, in which case I'm going to have a really big, that would be over released IDs here, and that could get really, really large? Or is it mostly just going to be new IDs getting requested, in which case this is going to be more or less almost zero, as only the handful of ones that get released I'll use, but otherwise this integer here will increase. So I guess I don't have like a one answer for you on that one, but it is really going to kind of depend on how it's being used.
Yeah, I think that makes sense though. It's like that's kind of it is dependent on the workload essentially, right? So it's not
exactly.
So like you said, we could talk about the kind of worst case, and we could talk about kind of like expected case as well.
Yeah, and I would say probably so the worst case. That's a good idea. So let's do that. So this one here would be the worst case. Worst case. And I would say the expected case, honestly, I would expect it to mostly be balanced, or mostly IDs being requested versus released. So I would actually expect this to be more along the lines of the expected case. Yeah.
Gotcha. Yeah, I think that makes sense. Okay, awesome. Yeah, so I think for the expected case, like we talked about, I think this is a pretty good solution, right? You can't do much better than a one for those cases.
Right.
So obviously that's not interesting. So what I do want to talk about now is the worst case.
Okay.
And specifically as we talked about, the worst case is this, where you have a huge amount of IDs in released. For at least worst case for this solution is you have a huge amount of IDs in released, and you're just taking up a huge amount of memory with your stack, right?
Right.
So what I want to do is I actually would like to try and like quantify not just like space complexity, but like actually like how much memory we're using. Because especially you talk about in like back-end roles, when you're deploying your services to production, you kind of need to be able to like reason about or allocate memory for your services, right? So let's try and think about like how much actual, not just space complexity, but how much actual like memory, worst case, given let's say 10 IDs.
Gotcha. Okay, so what we're storing here is a 32-bit integer, which is 4 bytes. So memory use equals 4 times n bytes would be the total amount of memory that we're using in the worst case here. Oops.
Yeah, and there's actually a bit of extra overhead too. Actually, like, are you familiar with how stacks are implemented in C++?
Thought they were implemented using a heap.
I think it was my understanding of the standard library stack is implemented using
a DQ. You're right.
Yeah. It's like just a kind of like a vector, but with 2 ends.
But I can tell it to use a vector instead. But you're right. But I don't know what that overhead would be for the DQ.
Gotcha.
Actually.
No worries. So I'm not expecting you to. This is why I wanted to talk through this.
Sure.
So basically the most like kind of array-based or like I guess the array-based data structures typically use, the reason it's O1 is they typically use what's called a doubling approach, where basically like let's say I have an array with 4 slots, right? I add 1, 2, 3, 4. Now I want to put something else in the stack. If I made a new array with 5 slots and copied everything over and then put 5 here, right? This would be basically O of n every push.
Exactly.
And every pop, right? Which is definitely not ideal. So what most of these implementations do is every time you need to reallocate, they double the number of things.
Yep.
So this leads it to being amortized constant time, because on average, like when you double it, if I have something of 4, that means if I double it now, my next 4 things will all be constant time. So even though I'm doing 4 extra work now, each of the next ones is only 1, so it averages out to like
Yep.
constant, right?
Yep.
So, but this basically means that if I have, n things in my stack, the worst case memory is actually 2 times that.
Right. So we'll call this actual memory use is going to be 2 times 4 n bytes plus whatever overhead of the DQ overhead. We'll put that in here.
Yeah, exactly. Some fields probably.
Some amount there, and even the vector is, I think, keeping track of the last index, etc. So good. So this will be 2 times 4, so 8 times the number of n bytes. Yep.
Yeah, exactly. So let's, as we talked about, this is an integer. So let's assume for now, n is like 2 billion. How many bytes would we use? Just to do some actual math.
Yeah, so that would be for 2 billion. This would be 16 billion bytes.
Yeah.
That's a lot.
Yeah, so it's 16 gigabytes, right?
Yeah.
Which is, modern computers have that much, but it's still like non-trivial for what we're trying to do, right?
Yep. Mm-hmm.
Cool. So now what I want to talk about is, let's assume that, constant time was super fast and we're actually not, bottlenecked on time, we're bottlenecked on the space. So what can we do to reduce the space used, even if it means making our time complexity worse?
Okay, because the first thing that pops to mind when we're talking about, limitations on space use is just setting a cap, right? And that would be pretty easy to do. Maybe in the constructor of the ID generator, we can set a maximum size for our stack. And then anytime it reaches that amount, we can just, instead of whenever something is released, instead of putting back into the free IDs, just doing nothing with it.
Gotcha.
So that's one approach, but that wasn't your question. Your question was, is there a way to trade off essentially time complexity for space complexity in the worst case that we're talking about up here?
Yeah. I do think we can also explore other approaches for just reducing space. I think, so the one you mentioned is an interesting one, but I think this basically has the same worst case as the initial solution we talked about, where you just increment an ID and never return it, right? Like you can easily imagine if, my stack has n things, that if I always have a kind of working set of n minus 1 things I'm trying to release, that I can pretty much always go back and forth between getting 1, releasing 2, getting 1, releasing 2, and then basically still build up this
Okay, gotcha.
So it's an interesting discussion. I just think that for the purposes of this, we probably do want to have the same behavior this solution has, where you kind of can guarantee that you don't lose IDs permanently, right?
Exactly. Yeah. Okay. So let's see. So what can we do? So really, the question is down here. When an ID is released, how can we trade off some time complexity to try to save on the storage that we're doing here? So I don't really know, but I guess if I think about it, right now I have kind of a dumb, I'll call it, counter down here. Last ID is just the maximum ID. The last ID that I issued, I'm just incrementing that by 1. So I'm wondering if there's somehow to add more information to that to help me reduce the amount of space that I'm using up here on the free IDs stack. So I'm just gonna kind of think through that for maybe a minute or so and see if I can come up with something.
Yeah, totally. That sounds good. And then no rush. We still have 20 minutes left.
Okay,
so
cool.
We're not under any time pressure. Kind of, as I said, with this problem, I was more interested in as we change up things and go peel back layers, seeing how we think about it. It's less of a code, 50 lines of intense code problem.
Gotcha. Okay. It's tough because I have no guarantee as the IDs are being released that they're necessarily going to be released in any kind of order. If they were released in order from the first issued, then that might that might give me a path there to kind of
Mhm.
change up the approach here. But since they could come in randomly, that's
Mhm.
that's the part that's kind of tripping me up here a little bit.
Yeah, for sure. It is tricky. It's tricky.
Mhm. Mhm. I'm wondering how the memory allocators do it now.
Yeah, yeah. Yeah. So I guess so. Yeah, it's kind of one way. Let's see. So one way to think about this, I guess, is like if you want to reduce memory usage, like
Mhm.
as we talked about, like maybe helpful to kind of just take a step back and think about like what, not in terms of like data structures or whatever, what do we need to represent about the IDs to figure out this problem, right? Like
Okay.
right now
Okay.
we're representing a set of freed IDs in a list, right? Like what else?
Yeah. Gotcha.
Like what do we
Okay.
need to know to yeah, ignoring code, whatever. What do we need to know
Yeah.
to solve this problem?
No, that's a solid hint actually. So, because if you think about it, really what I want to know is a set of intervals that represent the IDs that are currently issued,
Hmm.
and then as ID is released, I can, either update an appropriate interval if that adds one to an existing interval, or just
Hmm.
add a new interval. So by storing intervals rather than actual released IDs, I should be able to, you know, I should be able to
Hmm.
reduce the amount of space complexity here. Again, at the expense of now I'm going to have to manage this list of intervals, which is going to add to my
Hmm.
time complexity.
Yeah. So that's an interesting idea. I like it. I think unfortunately this doesn't actually save a workspace space. Because like let's say I do the
Mhm.
workload,
Mhm.
I get a ton of IDs up to n, and I do release um, 0, 2, 4, 6, 8, 10, 12.
Mhm.
Right now my
Mhm.
release interval is going to be a bunch of one
Each
things
interval
up
has
to n
one.
over 2. Right.
Ah,
So it's
yeah.
an interesting idea. I do like that. But I think for this, this specifically does not. The worst case is still that, right?
Worst
I
case
think
is
I
that.
agree. The expected case would probably be good, especially
Mhm.
because if you think about like a service deployment, if services start at the same time, you can imagine that could mean they're also likely to stop at the same time,
Mhm.
right? So giving them kind of consecutivities could make sense, but yeah. So I like that idea, but I think this still has the same worst case.
Okay. Yep. I think you're right too. And I was actually just getting ready to say the same thing, honestly. So,
Okay, yeah, yeah. Sorry for
okay.
stealing your
So,
thunder then.
so back to your point from before, then, and kind of take a step back and think about what was it you said? What is the information that we need about the
Mhm.
IDs? Hmm. Okay. So I guess we could invert it, although I don't know that this would necessarily be much better. But
Mhm.
it would kind of be similar to what I had started to write at the first, where rather than storing the freed IDs, I store the released IDs,
Mhm.
and then yeah, I store the released IDs. No, I'm sorry, I store the issued IDs,
Mhm.
so that now whenever a new ID is requested, that won't be at constant time anymore. That'll likely be, well, I guess it depends on how we store it, but it'll
Mhm.
probably be an O of n operation. But now in the worst case up here that we were talking about when we have a ton of released IDs, I'm now going to have, a constant time or a constant space complexity. But
Mhm.
this is just exchanging one worst case for another, because now if I
Mhm.
have a ton of requests for new IDs, I'm back in the same situation.
Right. Yeah. Yeah. Exactly.
Yeah. So I don't know that that's necessarily any better.
Yeah, I think that makes sense. Yeah, it's a lot of trade-offs, right? And that's kind
Right.
of the
Yeah.
why this is interesting, I think, because there's not necessarily like the obvious always best solution,
Yeah.
which is why it's fun to talk about.
Yeah. Well, it is. Yeah, definitely super interesting. But I'll tell you what. I'll be honest. I'm a little stuck as to
Hmm.
how to move forward here.
Yeah, no worries. No, so I think you're definitely on the right track. I think there's basically just one way of framing it that hasn't come to mind, which
Okay.
is a kind of a not necessarily obvious. But
Okay.
so let's talk about another way. Let's say that instead of trying to store the set of IDs that are in one state, like store all freed IDs or all used IDs, What if I basically just tried to track for each ID whether it's used or not? Like kind of frame it a separate way. Instead of a set of all things in one state, just a for each ID is it used or not?
I see. So how would that help us? For each ID, is it used or not? Because what comes to mind when you say that is something like a map
Mm-hmm.
where the key is the ID and the value is whether or not it's used.
Yeah.
So as IDs are requested, then I would add a key. I guess this would look more like this,
Mm-hmm.
etc.
Mm-hmm.
And then as someone comes in and releases it, I just come in here and put this to false. And now the next time one is requested, I got to search through and see if I can find one that's false to return that one instead and flip it back to true.
Mm-hmm.
Now, the reason I'm hesitant here, though, is because what's going to happen here is this map is just going to grow with the total number of IDs that's ever been issued.
Yeah.
Yeah.
Yeah. So I think we can't avoid the space complexity of O of number of possibilities for the worst case, basically.
Okay.
So it's just about how much like can we save on space, assuming we have to store something for each ID.
Right.
If that makes sense.
Yeah. Well, I still don't think that this would be better than our O of released IDs up here, because this map, because released IDs is always going to be less than or equal to the total number of issued IDs.
Yep.
So this map is always going to, so yeah, this worst case is going to be the same as the one we were looking at already.
Yeah. Yes, so that's true. But I think we can basically just do, like this approach, when you take the map of int to bool, we can do this in a way that's much more memory efficient, right?
Okay.
So let's say I have, 2 billion IDs.
Mm-hmm.
What if I just had an array of bool of size 2 billion?
Right. Okay, so that would be more space efficient. And then here the index equals the ID, and then the value would be equals issued/not issued.
Mm-hmm.
Okay.
Yeah. And so how much memory specifically will we use for this type of approach?
I see, because a Boolean is 1 byte, not 4 times 2 bytes. So this would be 2 gigabytes RAM. Aha.
Yeah, exactly. It's not better space complexity. It's a lot better, right?
It's a lot better. Yeah. Okay. So see, I was getting all caught up in the fact that the size would be the same, but this makes a whole lot of sense. I'm storing a smaller bit of data so that overall the actual amount of RAM used is lower.
Exactly, yeah. No, that's kind of the thing that is tricky to realize when you want to optimize memory. And this is kind of a good tip in general for optimizing memory usage, is either store fewer things or store each thing more efficiently, right?
Yeah. And honestly, to what you were saying earlier, kind of taking a step back, because when you think about, the time of the space complexity, you're thinking about how does this grow with the size of the input.
Yeah.
But once we're working on the optimization at the level that you're talking about here, I'm no longer talking about how does it grow with the size of the input. I want to talk about the discrete amount of memory being used.
Exactly.
What can I do to try to optimize that a little bit better?
Yeah. So I apologize if I didn't make that clear. That's my bad.
No, you did. I just haven't come across this type of question before yet, so it was just unfamiliar to me. But now that I have kind of that context, the hints that you gave were really good. Yeah.
Okay. Awesome. Yeah, I'm glad this makes sense. Cool. So let's talk about with this bool array approach, how would I implement my get and release ID? What would that look like?
Sure. Okay. So with the bool approach, what I would do. So the get ID, this would have to necessarily, I think, well, again, it depends on the data structure you use. But if we're just using an array here, this would be O of n for get ID, because I have to iterate through that whole array to find the first false. and then that'll be the ID that I return. And in the worst case, that would be at the very end or right next to the end or near the end. For release ID, would be the same actually. Because depending on where in my array it is, I have to iterate. Well, actually, no, this would be constant. Because I have constant access. So you're telling me to release index I. I can, in constant time, access that index and flip that to false for release ID. These are time complexities.
Yeah. And so then also talking about the case you talked about earlier, clients being well behaved. This also let us handle a release ID for MD that's like already been released, for example.
Well, it won't blow up because I'll just, if that ID is already set to false, it'll just set it to false again. It'll be a no op. Hopefully the compiler can optimize that away. But it also is not providing any feedback either, right? So, so that's kind of a trade-off there, is that the client won't know that it tried to release, really it probably meant to release that ID to a different generator, maybe on a different server. And I'm not giving you that feedback here. I guess I could actually make release ID a Boolean return value, and if it's already false and you ask me to return it, I could return back, a false instead of a true there.
Yeah, I think that would make sense. Cool. Okay. Yeah. So do you think we can implement that? See how it looks differently?
Yeah. How much time do we have left? Just a few minutes here.
7 minutes.
All right. Let's see. So I know we talked about an array. I'm going to use a vector here, which, like you talked about earlier, it's a array underneath the blankets there, but it'll just kind of dynamically grow for me. And this will be a bools. And now, when you release an ID, and I know that there's some algorithms in the standard library that can go through and find the first one. I just don't remember them off the top of my head. So I'm just going to iterate through my vectors to find the first false. So first thing, if it's empty, then what I want to do is so if it's empty, no, this should be pushback true. And then I'll give you the 0th ID there. Otherwise, let's go through and, in fact, this will be at the end. So first thing, iterate through it for if IDs at I equals false, flip it to true, and then return that index. Otherwise, I need to do this. So here I'm adding one more, and then I'm returning the size minus 1 because the size is always going to be one more than the last index that we added. And this should be, I don't think this bracket belongs here. There we go. Now for release ID, this should be pretty easy. So again, talking about misbehaving clients, they might give me an ID that's outside of the IDs I've issued already, in which case I just don't do anything. Otherwise, I take that and flip it to false. Yeah, I think that should do it.
Okay, nice. Cool. Yeah, I think that makes sense. Obviously, yeah, as we talked about, just trading off space
Mhm. Mhm.
for time. So I think, but I think, also obviously this, if we were memory bound, could definitely be a good trade off, right? Um,
Absolutely. Absolutely.
so okay, cool. So now, so about 5 minutes left. So I just kind of want to talk a bit more about the kind of the stuff we mentioned earlier. So for example, we were talking about concurrency and what happens if we have multiple clients accessing this. Like, how can
Mhm.
we make this handle that?
So the first thing that comes to mind is adding another member variable to our class here, a mutex,
Mm-hmm.
so that we can lock it. And then I would essentially do, what would I do here? I think it goes like this. So this would create a lock using that mutex, and then the next guy who came, if another thread came in and tried to use this while I still have the lock on here, it's gonna block until the lock is released. And then the way this works in C++ is once it goes out of scope, it'll go ahead and release it. So this will create kind of like a backlog if multiple threads try to access it together, and then
Mm-hmm.
it'll just let one in at a time, each one locking it as it comes into here.
Gotcha. Yeah, yeah, that makes sense. Um, okay. And so where would you unlock this, or how would it?
Yeah. So again, I think yeah, how do I unlock this? Actually, I think the way this works, yikes, I haven't done this a whole lot.
No worries.
Um, I think it's actually like this. So I think this returns the lock, and then when my lock goes out of scope, it releases the lock.
Mm-hmm.
And then the reason we need this class, the mutex class variable, because everyone uses the same mutex to try to get their own lock. But if one lock's already been issued, then it's going to block until they can get their own. So this, I don't think I have to release it manually, is what I'm saying. I think because of the RAII stuff, it'll do it for me when it goes out of scope.
Yeah, that makes sense. Okay, awesome. Cool. So would you also have to put that in release IDs too?
Yes, absolutely. Do I? Let's see. Yes, I do. And in fact, if I wanted to get really fancy, I'd put it right before the access here.
Yeah, that makes sense. That makes sense. Okay, cool. So yeah, I think that makes sense. So we had 2 minutes before I wanted to start talking about feedback. So this kind of seems like a reasonable stopping point, unless there's kind of
Okay.
anything you want to talk through or anything.
Sure.
So yeah. So okay. So I interview mode over. Yeah. So I definitely want to give you some feedback. I'd also appreciate any feedback you had for me as well. We can also
Mm-hmm.
kind of walk through typical approach for this question, what people do, basically anything that you want. But I guess first, let's start by giving you some feedback. So overall, I thought you did really well in this question.
Okay.
I thought I liked how you broke down the problem space. I definitely don't expect people to always realize that, like kind of reframing of the problem, right?
Mm-hmm.
And like how to just track, instead of tracking a set of IDs, track for each one, whether it's used or not.
Mm-hmm.
So I think I like that once I gave you that hint, you were kind of able to run with it and implement that and figure this out. And in general, because you said you wanted to focus on problem solving, like this is a very kind of problem solving focused problem, right?
Right.
So the lines
Right.
of code we wrote was like 20 maybe.
Yeah. Yeah.
But yeah, I definitely wanted to do this problem for that, especially since you mentioned you're also kind of more back end focused. So I think I definitely got to see kind of you showcase your problem solving. You walked through a lot of different potential solutions, talked about their trade offs.
Mm-hmm.
I think you clarified the problem well at the start. That's something I typically see people trip up on, is like not understanding the requirements, and specifically like the ID size, concurrency, like the uniqueness requirement are things that are really important to get right for this problem.
Okay.
And also, talking about clients being well behaved and some of those other corner cases, I like to kind of identify those. So I think the one thing that I think I would recommend is, I know at the start we kind of talked about like a brute force versus an optimal solution. And this problem, as we kind of ended up seeing, there's not necessarily a most optimal solution. It's all trade-offs,
Right.
right? So, I mean, for a lot of problems, there is just straight up a worse in a better solution. But I would potentially frame it instead of specifically like I need to find a bad solution and a good one. Just frame it more as thinking about like the potential space of solutions and like what their trade-offs are. And if you find one that is better objectively, and that framing it that way also specifically, in my opinion, helps you articulate why one is better and one is worse, right?
Got it.
Because you're like, oh, I could solve the problem this way or this way, not like here's the brute force, here's the optimal. Be like, I can solve it this way, this way. I'm going to go with this one because of these characteristics would make it more optimal. That kind of frames it more as like problem solving instead of just like, oh, there's a bad solution and a good solution. Does that make sense?
Yeah, absolutely. That's great feedback. I appreciate that.
Okay. Yeah, that was kind of the main thing that stuck out to me in your problem solving specifically. But overall, besides that, like I said, I liked kind of your clarifying questions, the way you broke down the problem space, the way you kind of took feedback and reconsidered, and when we had to kind of change the requirements or reframe the problem, how you kind of took that in stride and were able to think through it. So yeah, I think overall, I think you did great. I think your problem solving is good. I'm optimistic tomorrow, but I guess it's always every interview is different, right? So
right. Yeah. So we'll see how it goes.
Yeah, for sure. Right. Well,
awesome.
Do you have any feedback for me or anything?
I think you did a great job kind of framing the question initially, answering my questions. You did a really you were good at identifying kind of when to step back and let me kind of flounder a little bit, but also when to kind of drop in some hints as needed and kind of guide me along. So I can only hope that I get an interviewer or interviewers like you tomorrow, because this was very kind of collaborative, very back and forth, which kind of it really takes kind of some of the stress off of me as a candidate. So yeah, I think you did a great job, and I don't really have any negative feedback for sure.
Awesome. Well, yeah, I'm glad to hear that. And I'm honestly I prefer these types of interviews in general, because I feel like what we do at our actual like software engineering jobs is not like here's this like contrived problem, go write code for it. It's like collaborating and discussing and identifying solutions to complex problems, and then like breaking them down into implementation parts. And so like I feel like, in my opinion, the problem solving and the collaboration is in my opinion, the coding part of coding interview is basically to make sure you know basics of how to code. The rest is like, can you work well with others, and can you solve problems that are unknown? Because that's kind of your whole job, right? To solve problems with code.
Right.
So cool. I'm really glad you enjoyed it. So I guess the kind of so as far as feedback on this problem specifically, so like I said, I think I like your problem solving approach. I think you might find it interesting to kind of go over some of the ways this problem can kind of typically go or evolve as we kind of dig into it. So one particular that I think you might find interesting is we're talking about basically using this array of rules, right, as a data structure to map this that uses, as you mentioned, 1 byte per ID. There's actually, technically all you need is just issue or not issue. Technically the minimum information you need to represent this is 1 bit, not 1 byte. Right?
Yeah.
And there's actually a data structure called, and I wouldn't expect you to be familiar with this, but a data structure called a bit set, which is basically, it's an array of bools logically, but the way it's actually implemented is it's just an array of bits, essentially. And so this would basically use 1 bit per ID. So it would use 1/8 of like 256 megabytes or something like that.
Yep.
Now, it has the exact same API as an array of bools, which is why I just didn't even mention this, because it's the exact same approach you would implement. But I just thought you might find that interesting.
Yeah, that's cool. And I'll look at that. Even if I didn't know about the bit set, though, if we had time, we probably could have gotten to there just doing bit masks on the bools that I'm already storing in there. So I'd get 4 spots per bool in my array. Yeah,
exactly.
Yeah. Cool.
So that's like you might find that interesting. And then the kind of one place you could take this as well, which obviously we didn't have more time, but if you have more time and want to dive even further into it, is like obviously now O of n time is less than optimal, even though we did reduce memory footprint. So there's kind of like you can actually optimize the time without using a ton more space. So basically what you could do here is basically the problem is, like you said, you have to scan the whole array to find a unset spot, right? So what you can do is you can kind of build you can call it almost like an index on top of this, of like, so you might have like a bit set like this. something like this, right? I'll put this up as a 4-bit section just for,
Okay.
so the problem here, like you said, is finding a false bit. You have to scan through a bunch of stuff to find one, right? But if I can represent for each section, are there any open bits in this section? Then I can skip entire sections,
Gotcha.
right? So I could basically what I could do, if I kind of have a 1 bit for each section, where this bit is essentially just the OR of all bits in that section. So I could say this is 1, or the AND of all bits in that section. So 1 is everything in section set, 0 is not. That's a 0. That's a 0, and that's a 1, right? Then if I'm looking to do this, I just got to find the first 0 here, and then I can go in that section. I know I'll find something.
Gotcha. Yeah. So and then again, the trade-off there will be that you have to update that whatever you have later on line 50. That'll have to get updated now also anytime that you issue a new ID.
Exactly. Yep.
Or release an ID. Yeah. Okay. Cool.
So it's a trade-off because you have updates are more expensive, but still not that expensive, and your searching is a lot faster. Right?
Exactly.
And you can even imagine building a tree of these, right? Where then you could take these 4 bits for them.
Be a 0. Yeah.
Right. So then and then you could basically. So this essentially builds a bit tree, is I think what this data structure is called, if it even has a name. But yeah. So basically, you could do this, and if you build this tree, it's essentially because you have log n things. It's like update is log n, search is log n.
Gotcha.
And you're still using. So because it's a tree, you're using a little more memory than this, but I think it's because it's less than 2 bits per ID because you have the exponentially decreasing level size.
Got it. Yeah.
Anyway, I don't expect everyone to get here, but it's just this is kind of where you can go, and I thought you might find it interesting.
Yeah, very much so.
So cool. Well, do you have any other questions or anything else you wanted to go over before we wrap up?
I don't think so. This was very good. I really appreciate you and your time.
Cool. Awesome. Yeah. Thanks so much for talking to me. Best of luck tomorrow. Hope it goes well.
Thanks. Appreciate it.
Cool. All right. Well, have a great one.
Thanks. See ya.